Everybody. So, looking at a drawing for the Galaxy 88 board, I had some people reach out to me and ask me if I'd help them, look at theirs. One of them was an 88, one of them was another variant of it. Basically, this the same issues with both. So the drawing I'm looking at, just for just so that everybody can follow along if you want to, is this one here. So the radios that people came in with were that they needed help with getting working didn't transmit. Basically, they got like a stuck on receive, but no real receive. It didn't receive, but it was stuck on receive. Yeah, that sort of a thing. And I was like, that just is like PLL out of lock, classic PLL out of lock. But in one case, the PLL wasn't out of lock, and I'll get into that one, while I'm talking about this, because that wasn't the case on one of the radios that they reached out to me about. PLL was fine, but it still wouldn't do anything. It still wouldn't switch states. So, you have multiple possibilities with this transmit receive switching. So that's what these three transistors here do. But before I get into this, let's just go back to the mic jack and follow it forward. So most people know ground pin 3, radio transmits, you let it float, it receives. So in this case, it goes in, PTT input, PTT output, literally just loops through. And we end up on this position 42 on the board, which on my board it is actually 42. And we follow it around. We end up in these diodes. Now this thing with this cap and all this stuff in here is going to confuse you, so just ignore these weird connections that are actually wrong and just follow it through this way. Draw that a little better, up that way, okay? So you have this diode here. You ground this out. You're pulling this voltage down towards ground. Of course, we're up here at this op amp. I think this is the point where people kind of get lost. It's like, because I asked that question. Did you check the op amp? You mean the microphone amplifier? Yes. Did you look at that one side of it? Well, why would I look at that? What does that have to do with it? Well, actually, it has everything to do with it. So, basically, this second channel on this op amp is configured as a comparator. So, it does what it says it does, what the name implies. It compares. You got one voltage compared to the other voltage, and if one's higher than the other, it either outputs, it slews towards the to the positive rail, or the other way it goes slews towards the negative rail. So in this case, the positive rail is 8 volts, negative rail is ground. So you're either going to have like around 8 volts or ground on the output of the op amp. So in this case, there's a reference. And remember, it's comparing it to a reference. So what's my reference? Is my other thing higher or lower than that? And of course, the circuit reacts. So we have a 15K here and a 10K. It's going to be around 3 point something volts, 3.2. So that's our reference. So if pin 5 is lower than pin 6 is 3.2 volts, so let's say pin 5 is a volt, pin 7 is going to be close to 0. It's going to get dragged towards the negative rail, which basically means this turns on, because you'll see it'll flow this way. Hence these diodes that are steering things. We'll get into the zener in a minute, but this will it will ground this out, and this will power the 8 volt rail for transmit, and you will transmit. If this is higher, then pin 6 is like 3.2 volts, which it would be because we have another divider here, 100K, 100K. It's going to set this up for around 4-ish volts. 4 volts is higher than the 3.2 volts. Therefore, this will slew towards the 8-volt rail. So you'll have around 8 volts. And now when you have around 8 volts, this zener breaks down at 5.1, which means that this transistor will turn on and this transistor will turn on, and you'll have 8 volts to receive. So that's it in a nutshell. So if you look at the voltages on these 3 pins, if you have a radio that doesn't transmit, you look at these 3 voltages, you're going to have a pretty good idea. You should have a pretty good idea where to go next just from looking at these 3 right here. You know, you could look at 5 when you squeeze a microphone. If you have around 4 volts, because that's what that will be, around 4 volts, you squeeze a microphone, that might drop to about 1 volt, because, you know, we've got like 0.7 volts there and a resistor and so on. So it might drop down around 1 volt. So if this is working and you're going from like 4-ish volts to like 1 volt, then this is fine. If this is around 3.2 volts, this is fine. If this is going from 0 volts roughly to 8 volts when you squeeze the microphone, then everything here is good, and you need to move on from here. That's the problem, is not here. But if it is, you're going to have weird voltages here, you know, or things won't change properly. Like for example, let's say pin 6 was not 3.2 volts. Say it was higher or lower. Like if it's higher, then you got a problem. Like if pin 6 was higher, which in the one example, when the gentleman called me and asked me to help, if I could help him look at it, his pin 6 was 8 volts. It's like, there's no way that it can be 8 volts unless you've got something wrong here with these 3 components. And, you know, I was like, just isolate pin 6, and then this junction came to the 3.2 volts. Like, you got a bad op amp. That's just simple as that. The op amp was just bad. But he had been messing around over here and had a bad op amp. In the other gentleman's case, this voltage was down around below 1 volt. It's like 0.8 volts. It's like, oh. So why would that be? Well, look at this diode. So if we sync the voltage this way, if something syncs it, like the PLL, it's not going to change states either. And in that case, it's actually a bad reference crystal. This 10.24 was bad. You know, put a scope probe on there. You got anything on pin 3? Nope. You got, you know, power on, you know, over here, like on pin 1? Yeah. Well, try changing that crystal. Did. And it came good. It fixed the radio. So both of those were fixed. One with a bad op amp and one with a bad crystal. Not saying that yours is going to be the case, but, you know, it just shows you that the issues could be rather diverse. But in both of those cases, nothing was wrong, absolutely nothing to do with the circuit. Now on the radio that I've been working on, that board, this circuit had been tampered with, and I actually had to fix this circuit because someone took this zener out and put a 4148 in there. And this will never work. This has to be a zener for this circuit to work properly. So that's basically this circuit in a nutshell. So, you know, I'm not the best at explaining things. I'm better showing and talking about it, like visually with the board and so on. But I figured I would give this a shot, see if this helps people. Now this mess in here, ignore all this. This cap has to do with the beep. And I already had been asked by one of the people that I helped, like, why go through all this with the op amp? And what it really boils down to is the Roger beep. This you know, non-inverting comparator, you know, has some hysteresis because of the feedback, because it's got some positive feedback, and therefore what you end up with is the beep plays. So you have this slope, this time right here, while the voltage is rising because of this time constant, where the beep is played, and then it shuts and then the radio flips over to receive. So there's basically it has a lot. This has a lot to do with the Roger beep, which is this over here. This is not drawn correctly. Obviously, because like I think I mentioned a few minutes ago, this can't work. So there's some connections are not supposed to be here. Let's put it that way. So that's why I said ignore this and just look at it. Look at this path only if you're having a problem with the transit receive switching. Ignore all this direct connection. Yeah, this is all wrong. So that said, off to holiday I go, and if anybody has any more questions about this, I'll be happy to answer them when I get back. So cheers for now. Hope you lot have a happy holiday, and I will catch you next time. Cheers.